Welcome back to Homework Help. Today we'll be doing Trig Identities, lesson 8.8, and we'll do these problems. So, before we jump into the lesson, there's something really important we got to talk about first, and it's this idea of the reciprocal. So, right here in red is a key mathematical notion. The idea that when you see the number 1 over anything, I'm going to call it monkey, okay? If I have 1 over something, well, that really just means it's the reciprocal of monkey, whatever that thing is in the denominator. So for example, if I have in this case 1 over 1/2, well, that's just equal to the reciprocal of the denominator, which is 2 over 1, which is 2. You might be saying, okay, but how? Why? Well, let me show you. I'll show you with this one example, and then if you'd like, you can prove it in the other examples for yourself. So in this example, I have 1 over 1/2. I have a fraction within a fraction. So the way I'm going to deal with this is I'll put my numerator over 1, and now I'm going to rewrite it like this. 1 over 1, and I'm going to multiply by the reciprocal of the denominator. Right? So remember that when we have a fraction divided by a fraction, we don't divide, we rather drop, switch, flip, or basically multiply by the reciprocal of the denominator. And then when we multiply fractions, we multiply straight across. So I have 1 times 2, which is 2, over 1 times 1, which is 1. Final answer is 2. So what happened here? Well, essentially, we just multiplied this 1, which was the numerator, by the reciprocal of the bottom. So that's why I say, hey, just flip the denominator. And we can practice these examples here too. So in the second example, it says 1 over 2 divided by radical 3. So without doing much any work, I know that that's equal to, anytime I see 1 over, I'm just going to write the reciprocal of the denominator. So these guys flipped. And that's the answer. So now it's a little more interesting because we see a trig identity in the last example. I have 1 over sine. Well, remember, if I see the 1 over, it just means, hey, give me the reciprocal of the denominator. You should remember from prior lessons that the reciprocal of sine is simply cosecant theta. And here we've discovered our first trig identity. For today's lesson, you're going to become very comfortable with these 4 basic identities. We already discovered the first one, that cosecant is really just the reciprocal of, that's how I'm going to translate the 1 over, the reciprocal of sine. Similarly, secant is just the reciprocal of cosine. Now, tangent and cotangent are a little different. You're going to remember, okay, because this is a definition. You're going to remember that tangent is equal to sine over cosine. And if that's true, then cotangent, which remember, cotangent's the reciprocal of tangent, well then cotangent is just going to be the opposite. Instead of sine over cosine, it would be cosine over sine, because after all, these two are reciprocals. So I'm going to prove for you why tangent is equal to sine over cosine, and then I hope that it helps you remember it for good, okay? So you're going to commit these 4 to memory. But just really quick, I'm going to prove that tan x really does equal sine x over cosine x. So let's use some of our old identities, which is that tan theta equals, that sine theta equals y over r, and cosine theta equals x over r. So what I'm going to do is plug in for sine x, I'm going to rewrite that as y over r. And then for cosine x, I'm going to write that as x over r. And on the left, I'm still trying to prove that this is all equal to tangent. So let's see what happens here. Well, I've got a fraction divided by a fraction, so as we mentioned before, that's really rewritten as y over r multiplied by the reciprocal of the denominator. So instead of x over r, multiplied by r over x. And what do you see happen? Well, when we multiply straight across, we notice that the r's cancel because it's the same in the numerator as well as the denominator. And so our final answer here is equals. On the top, I'm just left with y times 1, which is y, over. On the bottom, I'm left with a 1 here. 1 times x is just x. And hey, wait a second. Isn't that our tangent formula? So I've proven that tangent is equal to sine over cosine. I hope you found that satisfying, but for our purposes, for the rest of the homework, I need you to just memorize it, okay? Commit it to memory, or have it on a flashcard next to you at all times. So again, these are our 4 major identities. Please, 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 please. I mean, just for the purposes of making your homework go faster, commit these to memory. Okay, so I do want to mention one more thing. If I asked you what's 1 over cosecant x, now that's not one of my formulas, but you should not freak out. Remember, 1 over means you should interpret that as reciprocal of cosecant. Hey, we know the reciprocal of cosecant. Its reciprocal is sine x. So I want you to have some faith using your knowledge of reciprocal identities to be able to rewrite some things that you maybe haven't seen before. So for example, if I had 1 over secant x, what would that be? This means 1 over means the reciprocal of secant. Well, the reciprocal of secant equals cosine x. Similarly, if I had 1 over cotangent x, that means the reciprocal of cotangent, so that's the same as tangent. And so on. I could do one last example. 1 over tangent means the reciprocal of tangent, so that would be cotangent. So please get used to seeing these in all their forms. We are now going to jump into our problems. Okay, so starting with problem number 3, our job is to simplify the trig identity. This is what it means to simplify. To simplify an arithmetic expression, it would look like this, 3 plus 5, and I would simplify it to just 8. To simplify an algebraic expression, 2x minus 6x, well, I would combine like terms, and that would simplify to negative 4x. So simplify just means, hey, take this unnecessarily complex expression and just simplify it. Make it easier to read. So we're going to do the same thing here with our trig identities using the definitions that we just learned. And here's our strategy, okay? This is the winning strategy, the strategy of champions. If you look at what champions eat every morning, this is their breakfast, is this strategy right here. It is to write everything in terms of sine and cosine first. That, my friends, is the winning strategy. So here's what it means. Look at the problem in front of you. Here I have cosecant x, and really it's being multiplied by cotangent x. Now I need to write everything in terms of sine and cosine. Well, right now, cosecant it's not sine, it's not cosine, it's cosecant after all. So I need to rewrite it in terms of sine and cosine. So I'm going to use this formula. So I'm going to rewrite cosecant as 1 over sine x. I guess I should color code these. Okay, cosecant is 1 over sine x. And I'm going to multiply that by cotangent. Well, cotangent needs to be rewritten as well. And I'm going to use the cotangent formula, which is cosine x over sine x. Now I have successfully completed my strategy. I've rewritten everything in terms of sine and cosine. And the reason why this is really powerful, what is happening? Cosine x, problem number 3. 1 second. Oh, I copied number 3 wrong. Okay, that's why. I made a whoops. Okay, let me go back a little bit. Let me do the actual number 3, okay? It says cosecant x times tangent x. Okay, but you got the gist, hopefully, of what we were doing. We're rewriting everything in terms of sine and cosine. So let's try one more time. Okay, I need to rewrite cosecant. So it's going to be 1 over sine x. Next, I need to rewrite tangent so that it's in terms of sine and cosine. So I'm going to use this formula, which is sine x over cosine x. And keep in mind we're multiplying, so when we multiply fractions, we go straight across. But wait, there's something I can do right here, right now. I see I have a sine x in the numerator and in the denominator. If I have the same thing in the top and the bottom, they can cancel. And so what I'm left with, now watch out, this is a common mistake. A lot of people say, oh, the answer is cosine x. No, not so fast. You have to multiply straight across. So keep in mind that in the numerator, I have 1 over, and in the denominator, I have cosine x. So that's very, very different from this answer, which is incorrect. 1 over cosine x is actually can be simplified even more because that's this identity. 1 over cosine x can be rewritten as secant x, and that's the final answer. So step by step, there's really no way to get stuck here if you go ahead and try and convert everything right away to sine and cosine. Let's do number 5. Okay, same strategy, except this time, instead of multiplying, keep in mind we're dividing, okay? But we'll do it exactly as before. I need to rewrite tangent, so I'm going to go ahead and do that. That's sine x over cosine x. Since it's being divided, I'm going to put a big fraction sign, right, division, to show that this is my numerator, and now I'm going to write my denominator. Instead of cotangent x, I'm going to rewrite it with its formula, which is cosine x over sine x. Now that I've rewritten everything in terms of sine and cosine, it's time to simplify. So we need to perform this division here. Well, when I have a fraction over a fraction, I don't divide. I'm going to multiply the numerator by the reciprocal of the denominator. So this guy gets flipped. So times by, instead of cosine over sine, I'm going to write sine x over cosine x. Now, you may be tempted, okay? I know that the temptation is there to cancel everything. But careful, these guys don't cancel each other out because you have to have one in the top and one in the bottom for them to cancel. So, unfortunately, in this case, nothing is going to cancel. But that's actually okay. We'll just do the multiplication then. So sine x times sine x will leave me with sine squared x. The way we write this is we put the squared between the trig identity and the variable, between the sine and the x. We do not write it. Okay, so I need you to understand that this is not equal to this. We need to write it right in the middle. And there are mathematical reasons for that, but you can ask your teacher later. Now in the denominator, I have cosine x times cosine x. So if sine times sine gave me sine squared x, then cosine times cosine will give me cosine squared x. And now I have sine squared over cosine squared, which looks really similar to my tangent formula, right? But notice the only difference is that here I have the squared on the top and the bottom. So what that means is my answer will simply be tangent squared x. It's going to match, okay? This is I only get to put the tangent squared because both the top and the bottom had the squared. Now that is our final answer, tangent squared x. Now I want you to notice something interesting from this step right here. Have a look. What's this equal to? Isn't sine x over cosine x actually tangent? And what about this? Isn't sine x over cosine just tangent? Could we not have realized from there that this is tangent times tangent and then gotten tangent squared? I just want you to see there are multiple ways to answer these questions. All right, let's move on to number 8. So I've taken away all of the notes because I want you to get used to remembering these formulas. So if you're looking at this and you're stuck, I need you to remember the strategy of champions. Convert everything into what? Sine and cosine. So let's do it. I'm starting off here with sine squared x. So that's already written as sine. We don't have to change it. We will just copy it down. Sine squared x, we'll simply copy it down, sine squared x. Now this guy has to be rewritten. So you have to remember your cotangent formula. We're going to multiply by cosine x over sine x. If you have your formulas handy, you'll see that that's the proper formula. Well, now everything's in terms of sine and cosine, and we're being told to multiply. So whenever we multiply fractions, we put this guy over 1, and we multiply straight across. But first, see if there's anything you can cancel here. Well, up here I've got sine squared x, and down here I've got sine x. That means I can cancel one of these sines. So I'm going to show that I've eliminated one of the sine x's from the top, and it crosses out with the sine x on the bottom. And in that sine x place, I'm left with a 1. So now let's do our multiplication straight across. What are we left with? I'm left with sine x cosine x over, and in the bottom, I'm just left with 1 times 1, which is 1. So anytime you're dividing by 1, your answer is simply itself. The answer is sine x cosine x. Now, there might be some people out there who are like, oh, sine x cosine x. Isn't that tangent? No, slow down. It's only equal to tangent when it's division, sine x over cosine x. That's tangent. Okay. So this is actually our most simplified version. We cannot do any more. Let's go to number 13. 13 introduces something new into the dynamic because now we have our first plus sign. And so when we have a plus sign like that, it's dividing our expression, or I should say it's separating our expression into two terms. This is our first term, and this is our second term. Now these terms, it's important to note, cannot cancel with one another. So for example, if I have sine x plus, I don't know why I wrote it like that, sine x plus 1 over sine x, you can put this over 1 if you want, but these cannot cancel with each other. You can't cancel over across a plus sign. So, keeping that in mind, let's just write a note to ourselves, which says, cancel only here. You can only cancel within a term. So, on one side of a plus sign, you can cancel. So, keeping that in mind, let's do what we always do. Our strategy, convert everything into sine and cosine. So this piece I can just copy it down because it's already cosine x. Next, I'm going to have to rewrite tangent. So let's rewrite it as its formula. That's sine x over cosine x. We're going to copy down the plus sign next. Notice how I'm doing everything step by step. I'm moving left to right across the expression. I'm not rushing. I know that eventually I'm going to be able to cancel these, but I'm not going to do it now. Just step by step, okay? Show all your work. Next, this guy over here is 1 over cosecant. I know I need to rewrite it in terms of sine or cosine. Well, if you remember that 1 over means the reciprocal of, this is the reciprocal of cosecant, then it should be pretty straightforward to remember that the answer is just, well, that's just sine x. Okay, this means you should interpret that. You should read that as reciprocal of cosecant x. That's what this is. And the reciprocal is sine x. So, next step. Let's see what we can do here. Everything's written in terms of sine and cosine, so let's put this guy over 1 and perform that multiplication. When we multiply straight across, but notice we can actually cancel this cosine with this cosine. And so what I'm left with on the left side of the plus sign is sine x over 1, or just sine x, plus, and then this guy stays sine x. Now, if I'm adding sine x plus sine x, this is like when you add in algebra x plus x. The answer is 2x. It's not x squared because we're not multiplying them. So similarly, here our answer will be, let's just combine the like terms. The answer is going to be 2 sine x. Notice the answer is not sine squared because this is not a multiplication symbol. But yeah, that's a common mistake, is to say sine squared. No. Just add them together, just combine like terms, and that's our answer. Okay, last problem. So now we have cotangent squared over secant squared. This is the only thing you really need to know to answer this question. If I have something like 1 over sine squared x, the answer is gonna, if this has a squared, my answer should also have a squared. So 1 over sine squared would be equal to cosecant squared x. You can't forget the squared. Similarly, if I had sine squared x over cosine squared x, the answer would be tangent x? No, I've made a mistake there. See if you can find it. The mistake is these guys are being squared, so my tangent must also be squared. Okay. All right, so if you understood that, then we should be able to solve this problem with relative ease. Let's rewrite the first term. Cotangent squared, so careful, we got a squared, we have to copy it. So this is going to be cosine squared x over sine squared x times secant squared x. So that's 1, technically it's 1 squared over cosine squared x. But 1 squared is just 1, so you can just write it as 1 over cosine squared x. Now let's see what we can do. Everything is now in terms of sine and cosine, and let's look for opportunities to simplify. Ooh, cosine squared cancels with cosine squared, and now I am left with sine squared x. See if you agree. If you are shouting at the camera right now, I'm proud of you because I made a mistake, right? My answer is not sine squared x, but really it's 1 over because I have the 1 in the numerator. So please, please, please don't just copy down what you see. Always follow the mathematical rules. We're multiplying, we multiply straight across. I'm left with the 1 here. 1 times 1, technically I have a 1 in the numerator. And in the bottom I have sine squared x times 1, which is just sine squared x. So I'm left with 1 over sine squared x. But that's not my final answer. I can actually simplify that more. 1 over sine squared, that's the reciprocal of sine squared x. The answer is going to be cosecant squared x. Don't forget the squared. I hope you found that video helpful. I'll catch you next time.